Okay, to start the discussion of the 4 or 5 terms that you have mentioned before in the past video or the previous video, of that all of them are the red pen, yes, all of them are the terms of the class of quality of service. I'm sorry. Some of them will occur at the receiving port, others at the transmission port, some of them at the bridge between them. There is some details about the bridging between TX and RX. Actually, it has been removed from the CCNA. It's only some explanation you are asked about right now, but in the CCNP you will configure quality of service. It's really complicated, causes some headache to configure and know the real in-depth information about quality of service. But you cannot build a network these days without quality of service. You can't. You need quality of service. So just in case we made, or I did, or I made, or I will make a CCNP course in the future, I hope so actually, then I will explain and do my best just to explain in details quality of service and their config and all the specifications needed to be known for a CCNP engineer. But for now, all what we have is the concept of congestion and quality of service, and after that those 5 terms to be known. The first 2 terms that works together, that they align together, are classification and marking, to classify and mark a type of traffic. It's talking about classifying the traffic according to its importance. This happens actually when I receive traffic on my receiving port and then send it to the transmission port. What will the transmission port do is that it will classify and mark the traffic that it just received from me just microseconds before it transmits it to the other end. And what really happens in here in this transmission port before sending it is classifying and marking. Classifying the traffic according to its importance, maybe low, medium, high, or very high. What do I mean by that is that actually nothing is automatic in here. The things that I'm describing for you right now, just to know, and the CCN exam, are just talking, and some description on quality of service. But in CCNP, you will see that all of those are manually configured. Nothing is automatic. Okay, so classifying and marking in the CCNP or the CCI, you will do it by yourself. You will configure it manually by yourself based upon the traffic that you are doing. So classifying and marking are, let me take this type of traffic and maybe assign it. Actually, you'll see that in queuing, or maybe in the upcoming slide that I will talk about. I will make UDP, which is for voice and videos, as very high, because I want no other thing to be transmitted before UDP. And after that, let's make the traffic of FTP, which is a protocol that I will talk about in this chapter, just after quality of service. I will make the traffic of FTP high, and I will make the traffic of maybe any other TCP thing after FTP. I will make it medium, and low, leave it for any other type of traffics, whatever it is, maybe for telnet or maybe for SSH. I will talk about telnet and SSH. I did talk about them briefly in chapter 1, but SSH will be discussed again in details and configured in 2 slides after that, and the end of chapter 4. So I will make all of this. I will mark FTP as high, I will mark UDP as very high, I will mark telnet or SSH as low. But classification is that when this TX traffic receives UDP from the TRX in the TX, and now it's meant to resend UDP, it will stop UDP and say, wait a minute, you are UDP and you are classified as very high. So you will be the first type of traffic to be transmitted, and after I finish transmitting you, guarantee that there will be no congestion by transmitting you alone, then I will start, after finishing transmitting the very high traffic, I will start to transmit the high traffic, which maybe it's FTP. After finishing transmitting the high traffic, I will then start to transmit the medium, and after finishing it I will start to transmit the low in this method. So classification or the classifying procedure or classification occurs in the TX just when a TX has some type of traffic, and this traffic is all manually configured by you in the future as a CCNP engineer, that you are UDP. Then wait, for the UDP I have this big section reserved for UDP, because it's very important, actually, not just because you are UDP, but because you are very important. So you have this big section reserved for you. So just sit in here for some microseconds and you will be transmitted directly, okay, to the other device. Once I finish transmitting, and I will drain or empty all this section in here of the very important or the very high priority, I will start after that with the high and the medium and the low in this way, those small. Okay, so let's make the very high this way, okay, and make the high this way, and the medium this much or this amount, and the low for this one. So when there is a traffic holding or queuing or waiting in this place for the very high important traffic, I will transmit all of this traffic and drain this one entirely so that no traffic will be left in here. After that I will start with the high, medium and low. So this is classifying and marking, is that I will mark this type of traffic as very high in the TX port. The important to know about classification marking is that where its action is being actually performed, where is the classification marking happening, or when or where they are occurring. They are happening or occurring in the TX port. So this is the important thing to know about classification and marking. Those are the two terms explained for now for classification and marking. But after that we have queuing. Okay, so queuing is actually just what's happening before classification and marking, just some steps before them. Just before the traffic reaches the TX, there is queuing, and the way happening to them is giving a specific priority to every type of packet. This is the real procedure that I have just mentioned some minutes ago, few minutes ago, that I will give the priority of very high to UDP. This simple procedure of making UDP very high is called queuing. So when the TX port at the classification procedure or marking procedure receives the UDP, it will say, oh, you are UDP. It seems that you are queued as very high. So you will wait in the queue of the very high traffic that I just showed you 3 moments ago until I transmit you first. After that, it will receive the FTP and say, seems that the FTP is assigned or queued as high traffic. So let me take it and put it in the classification, or classify it in the high TX reserved area or port, and in my port. Okay, so this is the first big benefit of queuing. The other bigger benefit of queuing is that it divides the transmission capacity, if you just remember it, with respect to the priority. Remember, just draw it this way, that almost half of the transmission is for very high, maybe 30% left for the high, some 20% for the low, and 10% medium, and 10% for the low. What does this is also queuing. Okay, classification and marking do apply the rules, but queuing do make the rules of this one is very high, this one is medium, give 40% for the very high, give 10% for the low. So it divides the transmission capacity with respect to the priority, maybe 40% to the very high, 20% to the high, etc. in this way. So see, so classification and marking are just listening to what queuing did manual by you. Remember, it's not automatic, it's manually done by you in the CCNP or CCIE exam. And after that, classification and marking will apply the rules that the queuing did. Okay, transmission, it will happen in the transmission port, first meant or first assigned by the queuing, after that applied in real life using classification and marking. For the third and fourth term to be known, which are policing and shaping and In the beginning, I have suffered differentiating between them because you will see that they work almost the same, but you will see this small difference between them. Policing is counting the traffic, counting the bandwidth of the traffic. Countings like this traffic is about 1 megabit, this traffic is about 100 megabit. So I will transmit the 100 megabit maybe per second, or depends on the reserved part or area in the TX port for the or the TX queue for this type of traffic. So policing is counting the traffic just before transmitting it, and you can limit it, like limiting the FTP traffic. FTP is actually the name of protocol, don't get confused. It's correct, I've talked about it in chapter 1 in IP parameters, but anyway, it's limiting the FTP traffic to be transmitted at a maximum of only 2 megabits per second. Yes, it's correct that my Ethernet cable, my fast Ethernet cable can carry 100 megabit per second, or maybe I do have just a normal ordinary old Ethernet cable, and old Ethernet cables used to carry only the bandwidth, or had the bandwidth of only 10 megabits per second. So what will happen is that I will serve using policing only 2 megabits per second for FTP. Don't get confused between FTP, the policing, and queuing, because queuing was reserving in the TX port using percentage, like give 10% of the traffic of the bandwidth for FTP. But now in policing, it limits transmitting FTP at only 2 megabits per second. Just in case, let's use the X and Y axis. I have just seen those before. Is that just in case you have a generated FTP that was, this is the limit of 2 megabit per second, that was trying to be transmitted to the other end. Once it reached 2 megabit per second, it will be transmitted all the time at 2 megabit per second. But the big problem is that, just check this, counting the desired traffic, which is counting the FTP, to limit it only at 2 megabit per second, but just in case the extra or what exceeds of the traffic will be dropped. Okay, so this must be applied for TCP only, because since it will be dropped, the excess of the FTP will be dropped, and FTP is TCP actually. We'll talk about it in the upcoming video. Just in case FTP will be dropped, some of part of the FTP will be dropped, it's better to be a TCP so that it will be retransmitted again. So policing is counting the traffic of FTP that wants to be transmitted and saying, you as an FTP, you will be transmitted at only 2 megabits per second. What exceeds from your transmission bandwidth that's needed to be transmitted will be dropped. And you as a TCP, this is your own problem, because you will have to retransmit yourself later, but never forget that all of your life, you will be transmitted at 2 megabits per second. But for shaping, it limits the queued traffic that's waiting in the transmission port or in the transmission queue for classification and queuing to a certain amount of traffic, limits the queued traffic to a certain amount of traffic, and what exceeds, is it dropped? No, it waits at the queue, it's not dropped. Okay, there is some extra queue hidden, like this is the queue of the TX, all of the traffic are in here waiting to be transmitted. Based upon this one will be transmitted at 2 megabits per second. This type of traffic will be transmitted by reserving 50% of the transmission port, the transmission queue for it. This one will be transmitted first because it's very high. This one will be transmitted last. All of those actions and complications are happening in the transmission queue, the TX queue. But when you apply shaping upon some type of traffic, it will transmit the traffic, the required traffic, yes, again, using 2 megabits per second, but what exceeds waits at the queue. It will not be dropped and needs the TCP to retransmit itself. It will be queued again, waiting for the 2 megabits to keep transmitting 2 megabits every second, and until maybe your traffic is 20 megabit. So you will wait for 10 seconds in the queue of the TX queue, because you are transmitting 2 megabits every second, because it's 2 megabits per second, until you finish all the desired 20 megabits per that I'm sorry, all the desired 20 megabit that are meant to be transmitted. So this is using shaping. The extra traffic will be wait or queued in the queue, the TX queue, but for policing, it will do the same thing of shaping, but what exceeds will be dropped, and it will poorly needs to retransmit itself using three-way handshake. Just in case it was TCP, be aware not to apply policing on UDP, because you will lose the drop packets that will never reach the customer or the other end. So 5 terms are explained until now. Yes, this is all you need to know as a CCNA engineer about quality of service. That should be enough, because you will see things in CCNP. It's really complicated in CCNP. When I was studying CCNP, I suffered with quality of service. I repeated so many times, tried to lab it. It's really complicated, but after labbing so many times, you will see that that's it. It's okay. I got with it, because it depends on a lot of numbers, digits, zeros, and ones. Some types, there are types for layer 2 traffic, other types for layer 3 traffic. There are some developed types, some expanded quality of service, I'm sorry, fields in the IP packet. A lot of talking, discussing, and labbing will happen in the CCNP or the CCI exam of the Cisco exams. But for the CCNA, you must know the concept of congestion, purpose of quality of service, the 5 terms of quality of service, who is doing what and at what time, or at which port, at which queue, which is the transmitting queue, and etc. So I hope until now the quality of service is clear to you. This should be enough to learn about in the CCNA exam. This is almost the end of chapter 4. Only 2 videos are left for chapter 4. So just check this, please. I will jump to the other video, and just in case this was not clear to you, just comment down below in the video of our channel. Subscribe. It would be kind from you to subscribe our channel. Comment below. Talk to me maybe more about, just in case you were curious and want to know the CCNP level of quality of service. Maybe I will make a special video or bundle of videos for higher level quality of service. Maybe we will lab it together, just in case you were curious and want to know. And as always, I will be glad to help you with that. So thank you for watching, thank you for your time, and see you in the upcoming video. Goodbye.